Hi guys. Sorry for the delay. I was having some technical issues. All right. I have to do some catting today, and I'm eating a bowl of fried rice. That's today's stream, basically. I haven't eaten in like since today. It's like I haven't eaten in like 12 hours, so I am eating right now. I have a bowl of fried rice with me. All right. So today, pasta. I like pasta. Yes. Is rice pasta? Okay, so I have to cat up two things today. I have to cat up the base for the project and also finish up the battery shell that I started yesterday. Yeah, so yeah, that's pretty much what we're gonna do today. I realize I do need these 5 holes because we're gonna have to like detect the voltage from each one. So I can't really. I was debating on whether to keep this structure or like remove it, but um, I decided to keep it. My dinner chicken can't dry. It's pasta. Oh, that looks good, Canarsa. Looks really good. I like it. I approve. I approve of the pasta. Yeah, that's pretty much today. I'm not gonna talk much because I'm gonna try to You're starving Bellum here. All right. So what I decided to do is I am going to go with what Ad Sandwich said yesterday. I'm gonna put like 4 solenoids on top. Um, 1, 2, 3, 4, and then I'm gonna put a little MOSFET circuit inside here, wired all in. And yeah, that's basically how it's gonna be done. Um, pretty much the battery there. And then I have to figure out like how to attach this top piece to it, but that'll come later. So for right now, we have our output mechanism. We have the way of assembling it together. We have the way of putting the wires in. Bare minimum way of doing that. A compartment for circuitry, a compartment for the connections. Um, and then just gonna make this look pretty now and add the top piece. Then you find out I should be ordering my food from your house. Hey, Cass. Yeah, Knarz looks like he's a really good cook. I'm just a little tired out from work lately. Um, that's a lot going on. 7 of 9 wood, making something to look pretty would be insufficient. Overwork. Yeah, I come back from work just to do more work on the side. It doesn't help that this room is like baking me like a chicken in the oven. These printers are really hot. I mean, in the wintertime, this would be really good. Maybe that's why my room is like never cold in the winter. I have to prepare for work tomorrow after this, too. Yeah. Gotta make my presentations for tomorrow. Yes, CAD. Alright. It's fine. Just to reduce the print time. Okay. It's gotta make something on here that makes sense. It would have to be functional with my brother from another mother. Have you considered AC? I do have AC already. PS and another father. True. Technically the truth. Me and the CAD. Yes, CAD is a thing. It is a thing indeed. Thing of beauty. Okay, I think this is good. Right. Right. Stuff happens like that when you like don't space it out correctly. This design should be fine. Oop. Just pop that up there. like less space in the middle too. There we go. Nice little shell now. Okay, my midterm pain. Oh, I solved that thing way back. Where is it? It's Sam. Yes, it's Sam. I don't have it on my board, but I've already solved the midterm. It's pretty simple. For multiplication, here are a few words about multiplication, right? So the maximum number you're going to multiply together is 512 by 512. That number counts to 262144. Now 262144, if you think about it, is actually 18 bits of information, because 512 is 2 to the power of 9. So if you do 2 to the power of 9 times 2 to the power of 9, you get 2 to the power of 18. So 18 bits of information. Now an integer usually stores up to, a signed integer at least, stores up to, I think, 11 or 12 bits. Maybe, no, it's 2 bytes, which is 16 bits of information. So it'd be 16 bits of information, right? So in order to get 18 bits of information to fit in 16 bits of information, you basically don't, because that's too short of a data structure. What you do is instead you go ahead and find a data or data type that can store more than 16 bits, maybe like 18 bits, right? Because 18 bits is 262144, and like that's signed. So you gotta think of like what data structure. Yeah, long. Yeah. So instead of int, you use a long, and that's pretty much it. There's a few extra steps, but that's pretty much it. And so long will be 7 characters, isn't that right? I want to redesign this so it fits a little bit better. It doesn't like fitting right now. I don't like those holes. Yeah, I don't like these holes. Can I change them? As my brain drips out of my ears, it still sounds interesting. Talk about bits and bytes and data. Okay, yeah, I just don't like this thing. Okay. So I remember that Add Sandwich said we want to kind of, battery holder, yeah. So we want to add an RFID chip into the head of the battery holder, so that it actuates the solenoids that are on top of it. And then when it does that, the battery will release from the drone using the 4 solenoids on top. You can make the package bulkier lengthwise. Because we're going to have to be able to balance the battery at the center of mass, like right here, and where this circle is. In order for like us to not have any like weight imbalance. I think the first course of action is to... It has a sad face, yeah. I'm gonna have to think about this back piece a little more. But first, let me just create the top piece, which should be as easy as like this. Oh. I'll also extreme this part. Alright. And then I'll just put the holes. So on the top here, holes. So I always mess this up somehow. You never know how many screw holes to put in this thing. I think one here. Oh. One here on the bottom. Like, I never leave enough room for screws. You're gonna stick a battery where? Inside inside a machine? And inside a drone? So 3 screws there. I think I'm gonna have to extend this top part just so I can put some screws up here too. Yeah. I looked time traveling in CAD just to fix my mistakes. Alright, I think these should be M3s. What are my M3 settings for screws? M3s. So as for the top, I need to map these onto the bottom first. Oh. So these 6 should be right. Alright, I think those are the right holes. And then these holes have to be threaded. Threaded M3s. Okay, so 3 there. I'm going to use M3 at 8s. So if I have 3 at the top, then I get 5 on the bottom. What? 5 millimeter. 5 millimeter doesn't work. Okay. I guess that's 3 by 12 then, so let's do 9 down. I guess it was fine with that. Sure. Alright, I'm just gonna like shell out the top piece. I'm just gonna go ahead and drill this out for now, because I might have to change this later, but I'm not sure. Just fillet the rest of the edges. I'll fillet this bottom face too. Okay, so the problem with this design now is that I'm gonna need to put the solenoid somewhere on the battery holder, because the battery holder is right, and it also has an extended piece. This entire thing will be printed like at once. Where do I attach it though? Because these two holes on the side here are going to be for the side attachments, for like the battery to clamp onto. But for the battery to hold onto the drone. I think I'm gonna put it on the drone itself. So that's what this hole's gonna be for. I think the drone's gonna go ahead and latch onto this area, this middle hole right here. How it's gonna do that, I have no idea. Actually, I do have an idea. What if let me just chain for the bottom of this thing first. Right, so what if this thing what if this thing had like an insert inside of it? So like, let's see. I had an idea to use like electromagnets to do this, but it's a risky one since there's a lot of power components inside this actual design as well. So if I go ahead and put like a really thin magnet on the back here, or some back extrusion, so that when the drone clamps on, it can like clamp onto the inner part of this. I wonder if that'll work. I wonder if there's anything thin enough to like actually clamp on that hard. Or maybe I'll have to like extend the wall a bit. So my idea is to have something like this on the inside. Or maybe a servo might work too. A servo might work as well. A very high torque servo, that's for sure. But something just to hold it in place. So here's the idea, right? Here's the idea. So we have like this kind of structure. And then on the outer edge, I'm gonna go ahead and make a rectangle. Maybe we'll make a center rectangle. Like right around here. Like this. Maybe this. I'll adjust the measurements later on. Right? So then I just extrude it to the back. Oh, hold on. This thing needs to go too. So something like this. It's a little bit too wide. 2081. Okay, yeah, something like that. So you insert the arm in and you rotate it, which locks it in place. What does the drone itself look like? Give me a second. There was a stream where I flew it indoors. It was a very bad idea. It looks like this. So it's a little Storm 4 drone with a Pixhawk, Raspberry Pi, and some other attachments on the underneath, and a little camera on the bottom as well. So there's a lot of like stuff on it, and a lot of like research has been done on this thing so far. So this battery carriage is going to go somewhere on the drone. So yeah, this locking mechanism should work. Okay, where's my midplane? There's my midplane. Okay, I'll just mirror this feature. The other side. Lock it. Okay, there we go. Basically, a nice little servo locking mechanism. That you can use. Maybe I can like put it on the top and bottom as well. Let me try that. So it would be this 21, 2, 3, 4. For millimeters like that, yeah. And then here, here. So I think it's gonna be like a four-arm wing. Yeah, okay, cool. So I'm imagining you put something into the battery, maybe like a lock and key. So like it's gonna be attached to a servo motor. You put it inside, and then it turns and it locks it in place. And then the rest of it can be held together by the supporting structure, right? I gotta put a notch once you turn it to lock it. Yeah, that's pretty much what's going on here. So this notch is going to allow some piece to go in, and then when it rotates, it'll rotate, and these four pieces will turn to the right or to the left. It doesn't really matter. And then it'll basically prevent itself from coming out of this piece here. It's basically a lock inside of this actual carriage, so that I can save space on it. And I can just put in like maybe a quick little design up here to account for this top area. Just like this. if you know anything about geometry, this is probably a good way to do like a really quick midpoint diagram. So I want to add more weight for the surface and just make it spring-loaded. We did make it spring-loaded, but that adds more weight to the battery carriage instead of the actual drone. So there's two parts to this. One is the battery carriage, one is the drone. And by making this more like a servo mechanism, it takes weight off the battery carriage. Instead of putting like a servo motor on here, I can just put the servo motor on the drone for it to lock. And also for the I can actually put it on the back here. So when the battery carriage slots into the mechanism, this is how it's going to be used to lock it in place too. So it's kind of like, instead of making it harder for the individual module itself to be working, I'm making this thing more transportable, while everything else I make, so for the battery to slot into, that's going to have the locking mechanism. Because when it was spring-loaded, the springs had to be attached onto the battery itself. Because the previous design was a spring-loaded design, and I just said I don't like that design, so I'm doing my own. I can show you, I think. Let me see. Where is this thing? Yeah, the previous project's loading up. The servos are not going onto the actual battery itself, it's going onto the drone. So the previous design looked like this, but the springs were actually on the servo, on this module itself, so it made it a little bit more complicated. It was on this little piece here. So to make it easier, because the springs had to be deloaded through these like bottom two areas, like these two pieces pushed in and caused the springs to contract and allowed the battery to push to be pulled out. This was like the locking mechanism, and it was like a little bit complicated. So there was a way to just, I guess, detach the servos from the drone before pulling out of this carriage. It would be a lot simpler. And then when it goes into some of these like storage units, which are going to be changed, it can like lock itself as well. I don't know. I'm just thinking of how this might be used. Like, to make this thing as simple as possible. I would not want. That should not be 2. That should not be 2. Maybe 1.5. It's a really large opening. You can see like right into the PCB. I'm gonna redesign this. I think I'm gonna make it a little smaller. Make it like this. You need a magnetic balls that slides into a groove that locks into those two each side. Just saying, through ideas, though, bro. Oh, that's actually a good idea. We were thinking about using an electromagnet in place of that, but the problem with the problem with magnets is that we don't know if it'll affect the rest of the system as well, because magnets and computers don't really sync well with each other, and plus it's a battery. So, although magnets would definitely be optimal, because actually, if they're really small, the electromagnets I was looking at yesterday, and also they were able to hold almost 50 newtons, which is 50 newtons of force, which this thing can hold, basically. So, in order to lock this in place, we just needed like a base plate, and then 2 servos on each side. And then maybe like two more on the bottom too. But it'd be much simpler to lock it in, I guess, at least from these 4 joints. So we can definitely experiment with magnets if possible. But I think just for safety, I think servos are a little bit more safer. just a tiny bit. Yeah, it's not a bad idea though. Oh, surface. No, no surface. I don't think it would be hard to experience to see the effects of it since you have a drone completely built. I mean, I don't want to rebuild the drone. That's what I'm saying. If I erase the data on the drone or like something else happens, maybe like if I have a magnet on it while the drone's flying and then it crashes, then I would have to like take time to rebuild the entire thing. All right. Or if there's some like voltage drop or voltage discrepancy. I mean, I do have some neodymium magnets. I can try to test it out like right now. I think. Maybe. Yeah, yeah, it's that's one of the things about magnets. It's a little scary if you don't know the exact effects it does, especially with something like drone flight. It doesn't just have to like wipe out its memory; it can also do some like fun other things. But these things are probably bad for the drone. Okay. So I think I think I'm gonna go ahead and expand this hole a little bit, just so that this hole is kind of like the bigger one. So it's gonna have like 4 locking points, I think, and I can just design the I can design this locking mechanism out of resin, and then have it slot in, and be attached to the servo. I think that way it would be a lot more compact. I gotta find a sketch that relates to this hole, though. It's this one. Make it 15 millimeters. Okay. So then I'm gonna go ahead and modify this. I mean, I already had a drone crash once because of the fact that I didn't know how to of the fact that I didn't know how to do how code works in the air. Here's to more drone crashes in the future. Okay, I don't know how large this is. Maybe 17, maybe 19. I'm not sure. No, I definitely think it's 18. No, it was 16. It was 16. I think I'm ready to print this thing out, by the way. So 16, right? And 4. And I just create a circle here. Circle here. Okay. And they extrude it out. Make sure you get all the parts. Okay, and then I'm just going to mirror this design to the other side. I used to select the entire feature. No. This feature and then the front feature. Near plane. There we go. Okay. So then you have 4 locking points on this battery. The top face, the side face, this part of it, the top part of it. Okay. I think that's should be okay. Should be fine. I don't know if I want to extend it out to the actual lock. I'm not going to. I think this is okay. So now I have to just redesign this gripper piece. So let me go ahead and joint these two pieces together first. One of these has to be grounded first. I'm gonna ground the main body. Ground. That doesn't move. And then I'll joint it. Why is it not letting me join things? It's like blurring them out. Let me just ground the... It was the ground. Alright, sure. Okay, so that looks fine. Neat little battery carriage with the locking mechanism in place. I don't want that fillet over here. I don't like that fillet being there. This thing. There we go. So this back piece isn't interfering with anything. Okay. All right. So I have 2 more things I need to do. One thing I haven't finished the sketch that was down here. It's body 11. Oh, that's the body 11. This is top cover. And I know why I didn't want it to function. It wasn't a component yet. Now it is. Okay. So I think one of the sketches I still need to work on is what over here. Sketch 14 is the PCB. So I think by default I'm just going to go ahead and make some holes on like the top corners. Here. Maybe like here and here. I'm probably going to use an M2.5 by 6 millimeter screw. So the PCB itself will be M2 point something. I mean, the target body's like right there. So it's going to be an M2.5. Sketch 14, which plane is this on? Is this on the bottom? Maybe. I'm just gonna delete it. Calculate. Alright, so I'm gonna redo the sketch up here so that it'll actually work. Hide the top cover. Point A, point B, point C, point D. Okay. Finish sketch. Make the hole. I'm gonna make it 2.5 down, or 3 millimeters down. I'll leave it 3 millimeters down. M2.5 millimeters. I don't know if my screwdriver can even reach the inside of that, but we'll find out. So I'm gonna attach a PCB to the bottom, which will regulate some things. And that'll be that. Top cover back on. So the only piece left to this is the grabber, so the top piece, which I'll have to redesign tomorrow. I'll also have to add some kind of activation mechanism, at least so that maybe include like a small RF sensor on the inside, so that it sends out an RF signal to the sensors for them to unlock. That might be a fun idea. Yeah. So maybe it's like some metal component on the arm. When it touches here, it sends out a small RF signal, or like some capacitive touch signal, in order to get whatever servo motor is like actuating this to turn and unlock the battery. Idea. Okay. I'm going to leave it for tomorrow, though. So, pretty good progress for today. We have a battery thing now, and I hope it works. I might just print out the main body on Belty with all the components on it to test out tolerances and such. But in general, I think it should be fine. Fine to work. This is a good Belty print. Belty will be able to print this. Thanks, Cass. Well, glad you're here for the ride. I'll move the battery clamp back in place. I think it was moved a little bit, just so it looks better, even though I'm going to change it later. Okay. That's pretty much how it's going to look like at the end of this, except this top piece is going to be different. And there we go. Fully built, fully constructed battery holder in 2 days. Render it. That's how it looks like. I wonder what happens if I like put some gold on it. Gold always makes things better. Oh yeah, look at that. Pretty cool. Oh, look at that shine. Looks like an apple pie. Look at that shadow. Shadow move across it. Alrighty. Well, I'm gonna leave it here for today. I'll finish the rest for tomorrow, and that'll be tomorrow's projects. 7 of 9, which says it's sufficient and pretty. Oh, thank you, Cass. Okay. That's it for stream today. Let's go ahead and raid someone. I'm gonna go ahead and finish up some work and prepare for my class tomorrow. The usual. Efficient. I hope it's efficient. Alright. Oh, we haven't raided Mo in a while. Let's go raid Mo. I don't know who 709 is. Is that like a I don't get that reference. If it's a reference, I don't get it. Someone's gonna have to tell me what that is later. I thought so. It's going straight over my head. Yes! Star Trek. That's probably why. I don't watch Star Trek. I've never watched it. Or Star Wars. I just know the name. Alright. I'm pretty tired, so I'm gonna go finish up some work and then head to bed. But thank you guys so much for watching. Hope you enjoyed seeing this golden thing. And yeah. I will see you all tomorrow. I have to finish this thing in 2 weeks. This is like Hyperloop all over again. Oh my goodness. Unfollowing. Oh no, Bellum, no. I just never had the time to. Alright, I'll see you guys. Bye for now. Oh, that's the wrong camera. That's the wrong scene. You guys saw nothing. You guys saw nothing. There we go.